Hi, Lesson 2 is all about seismic waves and some of the properties of the different types of seismic wave. To get us started, on page 2 of our booklet, you'll find a diagram that looks very similar to this. You can see that there are 5 terms labelled up on this diagram. What I'd like you to do is annotate the diagram to see if you can come up with a definition for each of these terms. You might want to do it in pencil, and then we'll confirm them in just a moment. Press pause now and give it a go. Okay, let's have a look at your definitions. We'll start off with this word fault. We're going to talk far more about faults in theme 13, but you can see from this diagram that the fault is a break in the rock. It's a place where rock is broken as perhaps two plates are trying to slide past each other. The focus then is the place where the seismic waves are actually generated. This is the place where the fault actually gets jammed, where the movement is stopped. When whatever's jamming those plates together breaks, and the plates can move very in a sort of quick jerk, the focus is where that actually happens. So it's the origin of the seismic waves. The epicenter, which is often talked about, for example, on the news when we're talking about earthquakes, is a point on the surface directly above the focus. So an epicenter you can plot onto a map. A focus, though, we plot onto a cross section. We can see on this diagram the seismic waves. The seismic waves spread out from the focus, a bit like the ripples in a pond if you throw a stone in. We'll have a look at those seismic waves in a bit more detail a little later on in the lesson. Finally then, we have this fault scarp. Now you don't always get this with a fault, but where you get some vertical movement, you can get an edge of rock pushed up at the surface, perhaps making a long ridge or a long chain of hills. Okay, now we've got our definition sorted. Let's think about seismometers, how we actually go about measuring seismic waves. Now, the old-fashioned way of doing this was on the seismograph. More modern techniques use electronic microphone type devices called seismometers to record the shaking created in an earthquake. Interestingly, the best way of recording that shaking is by an electronic version of what we used to generate with a rotating drum of paper and a pen moving across it. Let me show you a video to show you how this works.
How a seismograph works. A seismograph is an instrument used to measure the movement of earthquakes. A weight is suspended in a way that allows it to remain still when the ground moves. Most modern instruments use an electromagnetic mechanism for this. A writing instrument is attached to the weight, allowing it to record the movement as it happens. The word graph refers to the writing action. Most modern earthquake monitoring uses seismometers, not seismographs, and record the movement of the earth digitally, or output the data to a seismogram, a printed version of the wavelengths on a large drum. These wavelengths that represent Earth's movements are so small that in order for scientists to study them, they have to be amplified.
Okay. A seismometer will record the arrival of different types of earthquake wave. There are actually 4 different types of earthquake wave, what we call P waves, S waves, and 2 types of surface wave. There are diagrams that you can see on page 3 of your booklet. Let me explain a little bit how they work. P waves are longitudinal waves. You can see the vibration is in the same direction as the way the wave is moving. It makes them the fastest. S waves, a little bit slower, are shear waves. They move vertically up and down, perpendicular to the direction of movement. The surface waves are different. The surface waves show some combined movement. We can see with the love wave a sharp movement from side to side. This can have quite a bad effect on building foundations. The Rayleigh wave, though, we get a vertical up and down as well as backwards and forwards movement. This can be really destructive for buildings. Okay, press pause now and have a go at the questions on page 3 of your booklet. Okay, once you've had a go at those, let's have a look at some of the answers. Part B looked at this seismogram. We can see here we've got the record of the different earthquake waves arriving at a particular seismic station. So for B1, the answer is a seismogram. Seismograph is acceptable, but really the modern way of doing this is a seismogram. If we look at the arrival of these waves, it will tell us the speed at which they travel. P waves are the fastest. They move at about 8 kilometers per second in the crust. S waves are slightly slower. They arrive a little bit later. They may only travel perhaps 5 kilometers per second in the crust. And finally, the surface waves, relatively sedate, 3 kilometers per second in the crust. Now, the wave that causes most damage is the surface wave. P waves and S waves really don't have a great deal of an effect in terms of earthquakes as hazards. The reason from this, I hope, is clear from the seismogram. We see the greatest amplitude of shaking, so the greatest amount of shaking from its normal position. And also, those waves go on for the longest duration. The longer it goes on, the bigger the shaking, the more damage that will be done. For those of you that had a go at the digging deeper question, we've actually done this as part of Theme 0, where the gap between P waves and S waves arriving can be converted into a distance, as we know the speed of these waves. Once we know the distance that a wave has travelled from 3 different seismic stations, we can measure that distance as a circle of a radius of that distance, and where those circles intersect, that's our epicenter. Bit more complicated maths, and we'd be able to work out things like the depth of the focus and also its magnitude. Okay, to conclude, we can see that there are different types of earthquake waves, each of which moves in its own way at different speeds. However, the earthquake waves that are the ones we're really concerned about in this theme are the surface waves. They're the ones that cause the damage. Next lesson, we're going to look at how we actually try and measure the amount of damage that's done.